This is a short instructional video designed to introduce basic data analyses using SPSS 16. Most of what is covered in this video also applies to SPSS versions 14 through 19. If you are not yet familiar with using SPSS to manage your dataset, please watch the other tutorial on data management first, available on the Scilab webpage or the YouTube channel in her image. To learn how to report these results in APA style, you can also look for the tutorial video on the Scilab webpage or on YouTube. Assuming you already know the 4 types of measurement, note that in this video, these are collapsed into 2 broader categories. Both nominal and ordinal measurements will be referred to as categorical data, and both interval and ratio measurements, which SPSS groups together as scale measurement, will be referred to as continuous data. That is, it can be measured on a continuous number line. To summarize categorical variables, you must report numbers that summarize each category. There are 2 common ways to summarize categories: counts, which are raw numbers, and percentages, which are a proportion of the whole sample. Both can be found the same way in SPSS. In the top menu, click Analyze, Descriptive Statistics, and Frequencies. In the dialog box, notice that by default, the box is already checked to display frequency tables. All you have to do is move the categorical variables from the left box to the right box. Notice that the categorical variables have icons that show the variables have groups. Click OK, and the tables will be displayed in the output window. Notice that there are blank categories in the first line of tables for Party and Vote 2008. Notice also that the labels for those variables and for the groups appear rather than the symbols used in the spreadsheet. This is because not everyone answered these questions. You can see these in the data window and replace the blank cells with another code, like X. Then, in Variable View, click on the missing column for Party and indicate that X should be considered a missing value. And do the same for Vote 2008. Run the frequency tables again using the Recall Recent Dialogues icon, and notice that the missing values are now labeled correctly. Although the frequencies, counts, for each category remain the same, the percentages now reflect the portion out of the people who responded, which is labeled valid %, and out of the whole sample, labeled %. Either of these may be appropriate to report in different situations. To summarize continuous variables, there are no separate categories, but rather numbers. So, you must summarize the variables with a measure of central tendency, or an average, and a measure of variability, which is how much each observation differs from that average. There are 2 ways to do this. In the same Frequencies dialog box, remove the categorical variables and replace them with continuous variables, which are marked with a ruler icon. Uncheck the box that says Display Frequency Tables, and click on the Statistics button. In Central Tendency, check the boxes for Mean, Median, and Mode. And under Dispersion, check the Standard Deviation, which is the average or standard amount that observations differ from the mean. Click Continue and OK. In the output window, notice that each variable appears in a column, and each statistic appears in a different row. Valid is the number of people who responded to that variable, and missing is how many did not. Mean is the arithmetic mean, the most commonly reported kind of average, whereas median is the middle value if you line up all the values from highest to lowest, and mode is simply the most common response. i.e. there are more 19-year-olds than any other age category in the sample. Then click on Analyze Descriptive Statistics and Descriptives. In the dialog box, only the continuous variables appear, so move each into the right box. Click on Options and notice that the mean and standard deviation are already chosen by default, but the median is not available this way. So just click Continue and OK. In the output window, notice that in this table, each variable appears in a row and each statistic appears in a different column. Compare the two variables for political orientation. The one from 1 to 9 has a mean that is exactly 5 points above the one that goes from -4 to +4. But the standard deviation is exactly the same. This is because it is the same distribution, but centered at a different point on the number line. Con 2, created in the data management video, was created to make it easier to interpret. You can see immediately that the sample is slightly more conservative, or positive, than liberal, which would be negative, if the average were negative. But the average is very close to 0, which indicates moderate. To summarize and analyze the relationship between two categorical variables, you must run a contingency table. This presents the same information as a frequency table, but each count is contingent on the level of a second variable. Click on Analyze, Descriptive Statistics, and Crosstabs. In the dialog box, place sex in rows and party in columns. Then click on Cells. Observed counts are checked by default, but you can also add percentages of each row, column, and out of the total sample. Click Continue and OK. The case processing summary merely lets you know how many missing values there were. If anyone had responded to one variable but not the other, then that observation has to be excluded from this table. The cross-tabulation below reveals the same frequencies we observed before. On the very bottom row are the counts in each party, ignoring sex. And on the far right column are the counts in each sex, ignoring party. These are called the marginal totals, and the grand total is in the bottom right corner. The joint totals are in the center. For example, the counts of Democrats within each gender, or the count of men within each party. There are three kinds of percentages. The percent of total is the proportion that each count represents out of the grand total. For example, male Democrats represent 5.2% of this sample. The percent within sex represents the percentage of a party within that level of sex. For example, Democrats represent 28.6% of all the women in this sample, and 18.8% of all the men. Likewise, the percent within political party represents the percentage of a sex within that party. Men, for example, represent 20% of all Democrats, but 30% of all Republicans. To see, for example, whether men are truly more likely to be Republican than Democrat, you can run a chi-squared analysis. In the Crosstabs dialog box, click on Cells and check the box for Expected Counts. Click Continue and then click on Statistics and choose chi-squared. Click Continue and OK, and notice that below the contingency table there is now a chi-squared test table. Read the top line for the results. The chi-squared test statistic is in the value column, and the p-value is in the sig column. Because the p-value is over 5%, we have no evidence that in the population, different genders are more likely to join different political parties. The relationship between two continuous variables cannot be revealed by comparing the two means for those variables. If there is a relationship between age and conservatism, then as age goes up, conservatism would either usually also go up, which would be a positive correlation, or it would usually always go down, which would be a negative correlation. Click on Analyze, Correlate, and Bivariate. In the dialog box, enter age and the political orientation variables. Click OK and view the table in the output window. The same variables are listed going down the left column and going across the top row. And at each intersection represents the correlation between those two variables. Down the main diagonal, from top left to bottom right, notice that each variable is perfectly correlated with itself, obviously, because they are identical. This is like saying, as you grow older, you grow older. Notice that age is correlated identically with both versions of political orientation, because a correlation is a measure of covariance, how they vary together. And you notice that the variance, or standard deviation, was the same for both versions of this variable. The test statistic, R, is in the top row of each cell, and the p-value is in the second row. Contrary to popular opinion, this sample provides no evidence that people become more conservative as they grow older. The analysis of the relationship between one continuous variable and one categorical variable becomes more complicated, so it will be addressed in the next video, Data Analysis Part 2. Thanks for watching.